Hi Gavin, I'm making this video of calculus AB, the 9 pointers. So there are 6 questions. This is the first question. One of the question I've just thought of making a video on it. So where you are going to use a calculator. So let me go through this so that you can have a look at home. So that may help. Okay. Pause the video for a while and read the question. So if you see this question, particle moves along the x-axis with velocity function is given, and also the initial condition is at the beginning time t equals 0, the position for A is given at 7. I just thought of showing the visuals here. So this is the starting point, and the beginning, the particle is right here. When s of 0, that means it's 7. So just a beginning part. So what are the questions? There are three. There are three questions A, B, C. So I'm gonna go for the first one. Find the acceleration at time t equals 5.1. So what is acceleration is? If you see, the first derivative is always first derivative is always the velocity, the second derivative is the acceleration. So what we do is, if you are given the velocity function, take the derivative of this, and we need to find at the time 5.1, at what rate it is acceleration, what is the acceleration at that particular time. So simple question, so take the, let's write it. So we need the acceleration. So acceleration definition is rate of change of velocity. So it is dv by dt. So that means we need to know at d by dt at v of 5.1. So if this is t, so we need to know at 5.1. So on your calculator, so before that, we need to know what is the derivative of the velocity. So I just try to make make it easy for you. Here, there it is. Okay, so what you can do is go to the y editor, then enter this velocity function because we are going to use it again. So put this whole thing equation right here because we need this. Then go to the second quit, click on the max, then the 8 because we need to find the derivative. So NDER, and then use this. This is what is going to pop up, and put the. Now, how do you make this entry? There's a shortcut. Instead of going to vars, you can directly go to alpha trace, and you will see a lot of all the functions popping up. And then the first one is the one that you already entered. So that's the one you click on. So that will come y1 here. This will be your x, because by default the t is x here. And at what point we want is, at what time is 5.1. So you click on 5.1, and what you get is, the answer that you get is velocity, so acceleration gives you plus, so this is what you're going to get, plus 6.498. Now this doesn't give us any information about the units, like let's consider meter per second. The velocity is, let's imagine this is in meter per second, doesn't tell you, but here if this is the case, then the acceleration will be meter per second. So for every second, so there's an increase, can you see plus sign, so the velocity is being added is plus 6.4, which is meter per second square. So that takes care of the first question. At the same time, I also forgot to let you know that in the beginning s of 0, I want to know how what's happening to this position function. Is it moving to the right, left? I'm going to show with the graph, but before that, let's first solve the problem. So I hope this is taken care of. Let's go to the second question. Find time t when the speed is 1, from 0 to 2. So with the first 2 seconds, we need to know, so what is the what is the speed? So speed is, by definition, speed is nothing but absolute value of the velocity. What is velocity? Is rate of change of, so velocity is nothing but rate of change of displacement. Now, if I'm standing here and I'm moving with the speed is 1 meter per second, so I can move to the right 1 meter per second, or I can move this side 1 meter per second. So if I move on the right side, and that's the origin of my this one, so that becomes positive. So if I move this side, the velocity is positive, but if I move this side, the velocity is negative. So, but the absolute value of the speed is going to be the same. So we need to know what is this. So how do we figure this out? Is again, we have already Vt here, velocity function. So go to the, again I made a little kind of a help to figure that out using the calculator. So I want to know what is this, when the velocity is 1. So for that you subtract 1, so that in the equation solver on your calculator we need to know 0 equals, so this is what you get by subtracting 1. So then go to the second quick maths. Now this is a shortcut here, click the up arrow and then you'll pop up solver directly, enter that and 0 equals. Now since I made a little mistake here because since we want to know the absolute value of that, so what I'm gonna do is before going here, I wanted to write here, to get the absolute sign, you go to second and catalog. That will give you this option, and inside you put alpha trace, enter, exactly like how I showed before. You'll get those equations and you just put it y equals the first one, enter, then subtract 1 and you get, so then you need to know what are the, at what time is this. So to figure that out, so you have option of from 0 to 2, there could be 2 answers because the particle sometimes moves to the right, moves to the left, so that's why put x equals 0.5, and when you put x equals 0.5, what you get is so this is what you're going to get, 0.7718. And also second time you put, so when you put this one, then to figure out what is the value on your calculator, so you can click on the alpha, the solve, green color solve, so alpha, enter. So what you do is once you put x equal, once you enter this part, then you click on this one and then go to alpha and then the solve. And this is what you're going to get. Then go back again to the same thing, and put this 1.5 because I want to know 2 answers. So that's the first answer, and the second answer will be x will be, in this case will be 1.4005. So these are the 2 values we get at 2 times, at time 0.5 second, and of course this is t is the time. That's the time. The velocity is one negative and positive, but the absolute value is the speed. So the speed is going to be 1 in those 2 cases. So that takes care of the. Let's go to the third part. Let me clean this up. I'm not going to use this at all. So this is not needed. This one also not needed. So that part is done. The main focus is this part. So C is Find the position of a particle at time 4 seconds. Is the particle moving towards the origin or away from the origin at time t equals 4? So such case, how do we know? Okay, this is easy stuff. Finding the position of a particle is by directly the formula. What's the formula for that is, so we have by second fundamental theorem of calculus, s of x at any time is equal to s of 0 in the beginning plus integral of 0 to this x and the velocity function. So this is what we are going to use. So since the question is asked at 4, so I'm going to put s of 4 equals, this is 7 because in the beginning the particle is 7 units from the origin, integral 0 to the 4, and this is your y1 because that's what we have already entered in the equation editor. So if you go to the enter this part on your calculator. Same. So how do we figure this out? Is same thing, second quit. Then go to the maths. Then click on 9. Then you will have this. Put this 0 and 4. And over here, in this, since the calculator will take only x here, put an x. So what goes here is the y1. So for that you can directly write alpha trace, because you're going to put that equation again. So that will go right here. Okay. So, and you get the answer, and the s of 4 on your calculator should give you so let me check what was the answer. So sorry, I took a wrong one. I did the problem. Okay. So you get s of 4 is 6.71155. That means in the 4 seconds, this is the position of the. Now the question, okay, I'll put it at positive. Now make sure, what does this positive means? At the 4 second, where is 6.4? 6.7 is, this is 6.5, somewhere here. So that's like 6.7. So that's the position this is S of 4. Just wanted to show it's here, right here. Now, question is, at that moment, is the particle moving to the left or to the right? So how do we know that? We need to know the velocity, because if the velocity is positive, it is moving to the right. But because if this is the origin, we need to be careful. Where is the particle? The particle is on the right side of the origin. So if you are moving to the right, the velocity also is positive. So we have to find the velocity. So what is v of 4? So velocity at time 4 is that means we just need to find the value. So go to the math. Second quit. And click maths. So second quit, math, and then you just put alpha trace. So that way you can get this is like, this is, I have took it as y1, y derivative is y1. So when you do this, you get y1, and then inside you put 4, and the answer that you get is plus 1 point, I will put it meter per second. So that means the particle is moving to the right side. So at that point, at that moment, the particle is going to the right side. I'll just show an arrow. So the position at the 4 second is over here, 6.7. This is the initial position. And let's go to the last question of the day. And did I copy the question somewhere? Okay, I think I forgot. So this is already, okay, this is already done. And the last question is, let me clean that part. So the D part is during the time 0, during this time, does the particle return to its, so that's another question, initial position. The question is justified. So why do you say so? Okay. Now that we know, if you see the geometry here, in the beginning it was at s of 0, and as of, we never know what happened after like 1 second, 2 seconds, 3 seconds, but we know at s of 4 it is 6.7, it's on the left side. So what I'm going to do is I'm going to check on what happened, where was the particle at 1 second, or 2 seconds, 3 seconds. Since this is already entered on your screen, on your calculator, we can easily figure out for 1, 2, 3. So I'm going to find all of that to know where exactly is the particle. So let me click S of 4, we already know. So that was S of 4, which I'm going to write here. But what is S of 1? Let's see. So if you click on this S over here, put a 1 here, and change this to 1. The answer that you're going to get is 9.4, of course 0.55. That means the particle is somewhere here. So at 9.4 will be somewhere here. This will be your S of 1. If you want to see the position of the particle S of 2, put a 2 here. This will be 2, and then you get the answer as 8.36. So where is the position is 8.36 over here, S of 2. And I want to know what is S of 3. Of course, this is not needed, but I'm just trying to show everything possible. If I put this as 3 and this is 3, that will give you 6.85. So that is 6.85 is 6, this is 6.7, and 6 is so close. This is 6.7, this is 6. So I'm going to make it up here and say, okay, this is S of 3. What's going on here is, so the question is, how do we justify that the particle has returned to the initial position? So the initial position is here, that's at 7, and at 4 seconds it was right here, but at 1 second it was on the right side here. That means from the 0, from 1 second to 4 seconds, the particle has already changed direction. So this was the initial. So in 1 second it was somewhere here, but then at the 2, 3, 4, it has crossed this again. Now what does this mean is, we need to use the intermediate value theorem, which says, let's see, what does it mean? So what it means is, we have a continuous graph, which is differentiable interval between A to B, and you will see that for A there will be FA, for B there will be FB, and then if it is continuous and differentiable, or suppose if it is closed and continuous, that's why existence of intermediate value theorem, which means if there is a function which is continuous in a closed interval, then these are the minimum and the maximum. Then for any k in between, it will always have a c between A to B, such that f of c is k. So that's called intermediate value theorem. So can we use this to justify our result here is, if you look here is S of 0, so here S of 0 was 7, now S of 1, what was S of 1? Check. S of 1 is 9.4 and S of 4, now I want you to focus on this. So 1 and 4, and you can see the 7, this 7, the initial position is 7, this 7 lies between 6.7, so I want you to focus this one and this one. And clearly 7 is less than between 6.7 and 9.4. And this is your 6 is S of 4, and this is S of 1. So between 1 and 4 seconds, the 7 lies between. So naturally for this 7, the position of a particle that we always one time between 1 second and 4 seconds where the position has to be 7. Now what I try to do is make this make sense out of it. I try to sketch the whole kind of. So on the graphing calculator, if you graph the velocity function, so if you try to graph the velocity function, this is the graph which will look like. So whatever I try to show, let me show geometrically how that works. Is this is the initial position, and what I did is the velocity, when if you see the main function, if you put t equals 0, the velocity is 4, and you can graph it also. So when you graph this goes, this is the velocity graph, and somewhere there is a point of inflection also here. Let's go, let's see. Okay, so this you can clearly see, but we don't know the graph of the position function. So how do we graph the position function? So just to get a clear idea about this, because I know that initially the particle is right here, so I'm doing the particle motion up and down. Here I showed you right and left. So this is the position, and also since I figured out the different position for 1, so for 1 it was, I think I forgot, S of 1 was 9.4. Now over here, where is 9.4 when it is 1? This is 8. So let me take, this is 9 and 10, and 9.4 is somewhere here. So this goes here. That's your 1 and 9.4. So this is 2, then this is the position 8.3. When it is 3, these are all the positions. So what I did is I wanted to know also the point of inflection, and so this part where the velocity is 0. So where is the velocity 0 is when t equals 1. So that part I already know. That's where the turning point is. So from here, that's where the turning point is maximum, and then also our velocity is at 3.6. So the position function, again, I put in the velocity equation. So if I put on the vt that up down, and you put t equals 3.6, you get this point, which I think you can, yeah, somewhere here I already marked it. You can check also, so it is 6.4 or something here. So how does the graph of the position function look like? So I'm going to graph it. Okay. So this is where it starts. So that's the maximum. So initial velocity is, this is initial velocity is 4. So it goes in, takes a turn like this. Okay. So within 1 second it goes back. And there is a point of inflection also here. This is 2.3. If you see the velocity is 0 here, which is acceleration is 0. So that's where the change in that's where the point of, so speeding to the left side, and then until here. That's the main one point of inflection. Oh, inflection. I forgot to even go. Okay. And then this is where another point where there is a turning point. So it goes like this. So first of all, this is concave down because the velocities are decreasing, and then from here they are again increasing, something like that. So even though the question did not ask how does the position function look like, but we can always figure out from the velocity function when the velocity is 0, and then those time you can figure out the positions. We can also know where is the turning point at 2.3, and that's where you can find the point of inflection, so change of velocities. So here the velocities are decreasing, and then velocities are increasing. See, this is velocity is decreasing until here, and the velocity is increasing. So we can think of concave down until the point of inflection, and concave up. So everything is right there. Okay, so that's how I end this one problem about understanding position function, velocity function, acceleration also. Then the sign matters also, whether you're moving to the right side or to the left side. Oh, and also know how to figure out whether the, okay, I forgot about this part. The important thing I forgot is the intermediate value theorem. Where this is I'm going to draw a dotted line here. This is the main one. And the question was, in this 0 to 4 second, during the movement, does the particle comes to the same, and you can see here. So there is always a point right here where the speed is going to be, so the velocity, the speed has to be, the position is going back to here, because we have seen the velocities are above. So during the first one, it was 1 second, it was 9.4, and then velocity was 9.4 here. Where was that time? Did I make a confused you? Just wanted to make sure, yeah. So this is the graph, and you can see this is 7, so that is, again it comes to 7 here, because where was that thing I just wanted to show? So this is a continuous graph, and we had figured out 1 second, and because we have already done the 4 second, that was 6.7. So this was, that was 1, and here. So the question was between 0, yeah. So in this one, this case, this was the position, and I took 1, and I tried to show here. So the graph from 1 to 4 seconds, of course, I try to, even though between 0 to 7, I try to, we've seen the position at 1 was 9.4, and at 4 was 6.7, and you can clearly see the graph is continuous, and between this 7 lies between the two, so because it is between this 6.7 and 9.4, so at that moment it has to cross a time there. So maybe, so somewhere there will be always a time that where that happens. The speed, the position is 7, so it is between. So that's because of the intermediate value theorem. I hope I made sense to you. So Gavin, just go through this. I'm sure you will get all the stuff what I'm trying to show. Maybe I went too fast. Anyways, next time I'll go a little slow, okay?